This is a production of Cornell University.
So this is, kind of a comparison of the NRCS programs versus what we're doing in just Maryland, which has a pretty robust program. This is a collaboration with my PhD advisor and with Dean Hively and some folks at USGS and ARS. So it's developed out of a larger program, and we're just kind of trying to add value to it. I do want to say that this was supported by Northeast SARE, so thanks to anybody who's from SARE here. So cover crops are very regionally diverse in their adoption. You've got some areas, especially out in the Midwest, where it's 0 to 1%, and you see that these are 0 to 1%, 1 to 5%, 5 to 10%, and then you see these red areas, 15 to 56%, and that's where Maryland is leading the way. We have really high adoption rates. There's a couple other areas of the country that, localized pockets, but Maryland is really the star, and I'll talk about why. So already, this was my title, Are They Working? I'm going to tell you, yes, they're working. Really, the question is, how well are they working? So here in the Northeast, we're especially interested in protecting water quality because of the Chesapeake Bay, largest estuary in North America. It's very ecologically and economically valuable to the area. It's also very densely populated, as we know, as well as dense with agricultural land. And it's got $10 billion of agricultural output. So it's not something to overlook. And Maryland is almost 100% in the Chesapeake Bay watershed. So there was political will in Maryland to really focus on protecting the bay. And so about 10 years ago, a little bit more, they came up with this program. It's different from the way the NRCS programs work in that it's available to every farmer every year. There's never a cap on how many years you can do it. There are caps on how many acres, but it's sort of like an enormous number per farmer, so that's not really an issue. And the idea is not so much to incentivize like the real enthusiasts, it's to get everybody on board. It's not just the true believers. This is just money in the pocket. So compared to the payments for EQIP in, say, Indiana, this is twice the amount of money. This was my first time seeing the New York numbers that you just presented, which are comparable to these numbers. But this is a lot more money than a lot of other states are providing through the NRCS programs. And farmers like this a lot more than some of the other governmental programs about cover crops. For example, in Denmark, there are mandatory cover crops, and they don't get much choice. So farmers like to get money instead of just being told you have to do this. So the way the program works is the farmer in the fall will make their plan for the coming season. They'll go to their soil water conservation district and they'll say, okay, I've got this many acres I'm going to plant, and this is how I'm going to plant it. This is how I'm going to terminate the crop. This is the species that I'm planting. All of this information is entered into a big database, and then the payments are scheduled based on that. And it's really simple compared to the NRCS programs where there's like a bunch of different options. It's like just basically, did you plant it by October 1st? If you did, then you get this extra bump in pay for being early. Did you plant it by the 15th? Well, then you get a bump for being sort of the standard planting, and then there's late planting after that. We really incentivize cereal rye because it is just so much more productive than all of the other species. So that gets an extra $10 bump. But then the entire purpose of this program is just water quality. It's just keeping nitrate out of the Chesapeake Bay. So legumes and legume mixes, which we're all really enthusiastic about because we're cover crop, true believers, are not really incentivized in the program because that's adding nitrogen to the soil. Yeah. Now, the sort of interesting thing is this harvested column. For many years of the program, but not this year, the program allowed you to plant a grass did not fertilize it until the spring, and then harvest it for grain the following summer. And so obviously wheat is a big option in the region. People were really enthusiastic about that. This is the first year that they are cutting that side of the program out. Now you get a lot less money for that, but that's just sort of on top of. I don't know. Right? They probably somebody caught them, basically, is what you're saying. I'm not super sure about it. So kind of an update from the numbers that we were just talking about. It's actually $22.5 million this year. So it's a good chunk of change, especially because Maryland is a relatively small state. This money wouldn't go that far in, say Iowa, but it goes really far in Maryland. Yeah. So the kind of questions that we want to address in the project that I'm working on are these incentives working sort of over time? Since the inception of the program, has adoption increased? Are these cover crops capturing N and keeping it from getting into the bay? And are the payouts sort of on the level with the amount of benefit that we're getting out of it? And so we're going to tackle that in a couple different ways and talk about a couple different data sets that we have available. So like I said, spoiler alert, are incentives working? Well, they absolutely are. So this is acreage over time. These are three big commodity crops, corn, soybeans, and wheat. And you see that now cover crop enrollment has gotten to be the largest crop in the state on a given year. And part of that is driven because of the wheat program and the other small grain commodities that for most of the program, you were able to enroll those in the program. But then it's also just, this is now, 54% of our entire state cropland is covered under the program in year, I think this is from 2016. I don't have the 2017 data in this figure, but it just keeps going up every year. But then the question is, what's the interaction between the timing of these various operations or the types of management that people do and the amount of money that we're spending? So this is, average planting dates for each field across all of the years. And this is following corn in the orange and following soybeans in the green. And you can see that the dates are very clumped together here. Actually, I have a pointer here. Yeah, so the dates are clumped together here where, there's sort of they go up and they go up and then they peak and then they drop off. Well, you can imagine those are the cutoff dates. If you plant by October 1st, you get an extra $5, $10. If you plant by October 15th, you get an extra $5, $10. And then the actual final date of the program varies from year to year, so you get kind of a trailing off there. So we see this real incentivization for farmers to say, oh, I'm going to drop everything and make sure that I get it planted on the very last day possible in order to get that, money bump. But that pales in comparison to the fact that they all want to kill it on the very first eligible date. I mean, not all. This is, like 10%. But so come March 1st, they're all out there spraying with a herbicide or tilling it under, disking it in. They just want to get it out of the field as soon as possible. Now, we, of course, want them to leave it in the field for as long as possible and plant green. You can hear about that later. But then after, that first 10% of folks kill their cover crop on the very first day, then you have this kind of long tail of, when the various kill dates are. You see some people are going all the way into May, and then the June and July is where we're talking about the commodity crops that are and so then the question is, over the years of the program, have these incentives that we really want people to adopt, have they increased in popularity? So you recall that like early planting gives you an extra $10, and so you would expect that, from the inception in 2004 when they were only offering, $20 to now in 2016 where you can get a maximum of, I think, $75 if you get like all the possible bonuses. are people going for that top rate? And they're really not. There's either, early plantings are actually going down, late plantings are going up. There's no change in no-till, and really no change in adoption of cereal rye. So kind of the takeaway from this is, if you allow farmers to get money from this program, they're going to be enthusiastic about cover crops, but they're not willing to change their operations. They're not willing to change their practices. They're willing to sort of get their foot in the door, but then they're just going to do what works with their schedule. So the money is not really driving changes in behavior. And why are we so concerned with early planting and late killing? Well, the program isn't concerned with late killing, which is a problem from our perspective, but not from the perspective of the policymakers. So this is sort of like your potential growing degree days on the y-axis versus a given planting date. And this is from the Y Research Station on the Eastern Shore, which is sort of the main cover crop hotspot in Maryland. And so I've got here the number of growing degree days you might accumulate until the cover crop goes dormant, so let's say January 1st, and then the first date you're eligible to kill, that's March 1st, and then through sometime in the spring, May 1st. So you see that in the fall, there isn't very much difference between years. We tend to have similar weather every year in the fall, and you get a lot more growing degree days if you plant early than if you plant late, maybe 2 to 4 times. But then we might have a warm winter where by March 1st you've accumulated a lot of growing degree days, or we might have a cold winter where you've had very little change from January to March. And so you don't see a huge increase, but you see them start to spread out from year to year. And then going into the spring, you see an actual huge increase in the number of growing degree days. And we know that is what really drives biomass. Biomass is what's going to drive nitrate accumulation. The problem is, the whole point of the program is to accumulate nitrate in the fall and keep it from being leached out over winter. So that's part of why the program is not really incentivizing later kill dates, because from their perspective, it doesn't matter. They think that nitrogen is already lost. We happen to think that there are other benefits to cover crops, but that's not really the point of the program. Uh-oh, have I done something to this now? Oh, I don't know. All right, so uh-oh. Okay, I'm going to set that down and stop playing with it. The way that we wanted to answer some of these questions, we've got a combination of some field studies and some remote sensing. And Dean's going to talk a lot more about the remote sensing piece. So we identified a bunch of sites over on the Eastern Shore. This is near that Y Research Station that I was talking about. And these are all very sandy soils. They're almost all altisols, light textured. And like I said, these are the top counties that are enrolled, the number 1 county, the number 4 county, and the number 3 county. And you see there are a bunch of other top 10s here on the Eastern Shore, as well as a few in Central Maryland. And so we went out. What am I doing wrong here? I don't know. Anyway, so we went out, and by we, I actually mean Dean and his team, because I don't know. Technology. All right. So we identified these farms. We went out and we took samples in the winter, sort of like when the cover crop was going into dormancy, and then in the spring after green up, as they're starting to accumulate a little bit more biomass. Took samples, analyzed them for CNN. And here you can see the real difference between a cold year and a warm year back to back. In a cold year, you accumulate very little biomass from December to March. In a warm year, you can accumulate 2 to 4 times as much biomass from December to March. So, that's something that we think is really valuable, but that's what farmers are afraid of. There's a lot of farmers who don't want to have that, high residue out in the field. And so as far as this program is concerned, as long as you're getting something here, that's a success. And the question is that enough of a success for all of the things that we want to achieve, like soil health, like phosphorus loading, and all the other things that could happen in the spring that are not being targeted by the program. So the program, has some diversity in it. There's radishes and there's legume mixes, but 90% of the farms enrolled are cereal, rye, wheat, or barley. And so this is not super important, but basically this is all of the management practices that the farmers are reporting, and did some machine learning algorithms on it. You can see that they cluster together is the point of this. And so they end up forming these clusters where people who are planting after soybeans tend to plant late. They have a variety of establishment practices. They plant a variety of species, but this is sort of one of the clusters. And then you've got people who are planting wheat. You've got people who are doing broadcasting of various varieties, people who are planting barley, and people who are planting rye mostly. So those are sort of some shorthands to think about these different clusters that came out in the data. And it's reasonable to assume that these management practices would vary together, because soybeans come out of the field later in our region, so you can't get your cover crop in until later. So then the question is, how do these cover crops perform in these clusters that I just came out with? And just as a reminder, after soybeans means late, wheat, barley, and rye means drilled, these small grains, and then broadcast is often earlier, but either aerial or just broadcast after the crop is harvested. This is the details of the model. So you see that we've got these nice lines that connect them, and some are much steeper than the others. And in fact, it's statistically significant that rye outperforms all the other clusters. And then our two small grains are next. And then we've got our broadcast and our after soybeans pulling up the rear. And so what that means is rye is just always going to be more performant than the other cover crops. It's just going to put on more biomass. It's going to salvage more nitrogen, no matter when you plant it. But then you've got, and you would expect that your wheat and barley would do well, but not as well. And what's interesting out of this is, even if you plant after soybeans, even if you drill in, even if you plant a good species like rye, you're never going to get that yield performance, because the slope of this line just isn't high enough. No matter how far out you go on these growing degree days, you're not going to get there. And that's a real challenge. So it's basically telling us that if you don't get an early establishment in the fall, you're not going to get a good stand. It's just never going to amount to much in the field. And likewise with the broadcasting, no matter how early you get it in, if you're not getting good seed-to-soil contact, you're not going to be getting a good stand, and it's never going to be able to catch up to your, sort of well-managed species. So then this is sort of the final researchy data bit. If you look at, this is kilograms of N that is in the biomass in the spring, divided by the number of dollars that are paid to the farmer. And it's very consistent, no matter whether it's in the commodity program or if it's traditional cover crop. Doesn't matter if it's between the different clusters here. Rye is a little bit better, but the median, this heavy black line, is pretty similar among all of these. So that kind of answers our last question of, are these payouts commensurate with the benefits that we're getting? And it seems like, yeah, they are. The ones that are poorly paid are poorly performing, but it ends up being kind of a wash in terms of N per dollar, which is one metric that you might use. And so the next step of this is that we're going to extend this analysis to use biomass estimates from satellite imagery, and Dean's going to talk a little bit about that. Hopefully And then we're going to test these relationships across soil and landscape factors, distance to the edge of a watershed and elevation, things like that. So just a quick conclusions. Cover crops behave like crops, and that's what we would expect. You need both early planting and good seed-soil contact in order to get a good stand to drive performance. And these small grain subsidies that were available in the program achieved a lot of the same goals of cover crops at a lot lower cost. So any other questions before I turn it over? That extension sociological component, it seems like, is very variable among different areas. There are some district agents who are going to be very hands-on, and there are others who, are not. Right. I don't know that the state has that on their radar. When I read through the meeting the meeting notes of sort of the most recent planning committees, they're not even thinking about trying to optimize the program. They're just trying to keep it going. Oh, I don't know. And based on what Dean just told us, sounds like probably not. Because if they're sort of shifting it from an incentive to a regulation.
This has been a production of Cornell University, on the web at cornell.edu.